today's lesson, we are going to be adding and subtracting radical expressions. When adding and subtracting radical expressions, we need to look for common radicals. So if you look up at this example, you'll see here that we have the square root of 7 and the square root of 7. These are common radicals. So 3 times the square root of 7 plus 8 times the square root of 7. Since we have common radicals, you're just going to add the numbers that are outside. So you're going to add the 8 plus 3, which is 11, and you're going to keep the radical underneath. So you keep the radical. It's like adding and subtracting fractions. If you're adding 1/2 plus 2 halves, you keep the denominator the same. The denominator comes across. Same sort of concept here. You're going to keep the radical. If you can simplify the radical, then we're going to do that, and we'll show you an example of that in just a moment. Okay? Here we have, again, common radicals. We have 9 times the square root of y minus the square root of y. In front of this root y, remember we have an invisible 1. So what we actually have on the outside is 9 minus 1, which of course is 8. And then we keep the radical. You're going to multiply that times the square root of y. And that is simplified. Now they're going to get a little harder here. If you look up here, you'll notice that there are not common radicals. Here we have the square root of 2. Here we have the square root of 11. Those are not the same. You first look to see if you can simplify them to create common radicals, but both of these are prime, so there's no way to simplify this. So now here we have 3 different terms with radicals being added together. Again, we're going to look for what we call like terms. If you'll notice here, we have the square root of 3d, and here we have the square root of 3d. Because those have like radicals, we can combine what's on the outside. So we have a -8 and a +10, and we know that a -8 and a +10 is equal to a +2, and then you keep what's underneath, the 3d. This does not have another term that's like it, so we're just going to keep that, so we cannot combine that to the 3d. So our final answer would have 2 terms, and it would be 2 square root of 3d plus 6 square root of 2d. So combining like terms. Here you'll notice that they are not common radicals, but you always look to see if you can simplify them to create common radicals. The square root of 12 can be broken into 2 factors, into square root of 4 times the square root of 3, because 3 times 4 is 12, and one of those is a perfect square. Remember, we want one of the factors to be a perfect square so that you can take the square root of it. And we know that the square root of 4 is 2. So here we simplify this to this 2 root 3. And with our second term here, the square root of 27, I know that I can break that down into the square root of 3 times this, or the square root of 9 times the square root of 3. 9 times 3 is 27. I can take the square root of 9, which is 3. So on this side, I have 3 root 3, or 3 times the square root of 3. Now look what happened. We were able to create common radicals so that we can now combine these as like terms. And 2 plus 3 is 5. So we have 5 root 3 as our final answer. So if you do not have like radicals, always look to see if you can simplify them. And remember with simplifying that we want to find one of the factors with a perfect square. Then you can combine them. Here we have 3 root 8 plus the square root of 45. We do not have common radicals, but let's see if we can create them. I know that the 8, one of the factors, is a perfect square. That could be the square root of 4 times the square root of 2. 2 times 4 is 8. 4 is a perfect square. 45, I can do the square root of 9 times the square root of 5, and 9 is a perfect square. I can take the square root of 4, which is 2. So on the outside, I have 3 times 2, which is 6. root 2. I can take the square root of 9, which is 3. So over here I have 3 root 5. I do not have common radicals. I did simplify it, but I do not have common radicals, so that is my final answer. That's as far as I can go. Here we're going to start doing sum with variables. Again, we do not have like radicals, but I can break them down. 28, I can break that into square root of 4 times the square root of 7. And our variable is x to the first power. It needs to be an even number to be able to take the square root of it. I'm just going to keep going here. We have 8, but 7x. 7 is prime, so I can't break it down any farther. But if I look at this first term, I know that I can take the square root of 4, which is 2. I cannot take the square root of 7 or x. They're not perfect squares, so I'm going to leave them underneath. On the outside, I have 5 times 2, which is 10. Underneath, I had left the square root of 7x. And here, I actually did create common radicals. So now I can combine the outside. So I have 8 or 10 minus 8. So my final answer would be 2 root 7x, or 2 times the square root of 7x. Okay, in our next example, we have 3 terms. None of them are common radicals, but let's see if we can simplify to create any. In the first one, we have 125. 125 can be broken into 25 times 5, and the b is not an even number, so it's going to have to stay underneath. I know that I can take the square root of 25, which is 5. So when simplified, I have 5 root 5b. With our next term, we have 3 times the square root of 20b. 20 can be broken down into 4 times 5. And then we have the b. I can take the square root of 4, which is 2. I can multiply these together, so I'd have 6 on the outside. And underneath, I have 5b. Notice that I have like radicals already. Let's look at the last term. 45b can be broken down into 9. Square root of 9 times the square root of 5 times the square root of b. I can take the square root of 9, which is 3. So I have minus 3 root 5b. So I've got all like radicals. So now I just have to look at what's on the outside. I have 5 plus 6 minus 3. So my final answer would be 8 root 5b. Okay, here we have 4 times the square root of 27 minus the square root of 18. We do not have like radicals, so let's see if we can create them. The square root of 27 can be broken down into root 9 times root 3. The 4 was out here. I can take the square root of 9, which is 3. So on the outside, I have 4 times 3, which is 12. And the 3 is still left under the radical sign. With the next term, I can break this into 9 root 2. I can take the square root of 9, which is 3. So I'd have minus 3 root 2. Here, notice we do not have like radicals. So that would be our final answer. We can't simplify it any farther than that. That is our lesson on adding and subtracting with radicals.